So today is October 25th. I'm making this recording with no class. So we tried to do it in class, but it didn't work out for a couple of reasons. We are doing a review of graphing. So there's two methods we've learned. So here's your bell work. You can pause the video, think about what the answers to that would be, if you can come up with it on your own. The main question is, how do you know which method to use? So the second question is the most important piece of that. Pause it. When you're done trying to figure it out, you can start playing again. So hopefully you're back if you paused it. So the two methods we learned were the yellow sheet, which was slope-intercept form. So that was one, and that was the yellow sheet. Or that the yellow sheet told you how to do it if it was in that form. And then the other we learned, I'll write it in, I don't know why I'm writing it in blue, but I'll switch to blue. So the other one we learned was standard form. So standard form was a white sheet that had the steps to solving. But the way you'll remember it is that's when we plugged in 0, plug in 0 for x, solve for y, and then we did the same thing, only we plugged in 0 for y, and then we solve for x. And I'm going to give you examples of these during the video. So we plug in 0 for y the second time, and then we solve for x. This is the same material, by the way, in the last video. Well, some of it's the same. It's a summary of everything we did last week, basically. All right, so the question is, how do we know which method to use? How do we know if we have slope-intercept form, which is where we use the y-intercept, and we put a point on that, and then we use the rise over the run, the slope, to get our second point. That's slope-intercept form versus over here in blue, the standard form. So the way we know comes from this. Actually, let me get rid of something. So those are two examples down here. So there's an example, two examples in red. I will put a box around them. So that's one example, and that's a second example. Those are slope-intercept form. Here are two examples over here of standard form. So there is only one thing you have to really do or ask yourself in order to figure out which format it's in, which form it's in. You find the y variable. So I'm going to circle the y variable. What color do I have? I've already used all my colors. Red, blue, green, and black. Yeah, I've already used all of them. I'll change colors. Let's make it yellow. I don't know if yellow is going to show up. We're going to use yellow. So circle, or not, you don't have to circle it, but find the y. There's the y variable. There's the y variable. Well, if we had equations like this, here's the y variable, here's the y variable. You ask yourself, once you've located where the y variable is, you ask yourself one question, and that is it. You ask yourself, is the y variable all by itself on one side of the equation? And again, the sides of the equation are separated by the equal sign that separates left and right, just like it did when we solved equations. The equal sign separates the left and the right side. So in these two equations over here, the y variable is all alone. There is nothing else on the left side of the equation right here. There's nothing else over here. It's just the y. On this equation, there's nothing else over there on the right side. It's just the y. If the y is all by itself, then you're going to use slope-intercept form, or I should say if the y is all by itself, it's in slope-intercept form. So you're going to use the slope-intercept method to graph the line. Now, really quickly, down here, do yellow again, I guess. We have a yellow sheet, if this is my Algebra 1A class at least. We have the yellow sheet. The yellow sheet is for graphing when it's in slope-intercept form. It says that at the top. You could just use the yellow sheet. I'd be fine with that. Or you could write all of this right here. That's a summary of how to graph when it's in slope-intercept form. I don't care what you take down for your notes. The key is you need to know when it's in slope-intercept form, and again, that's when y is all by itself on one side of the equation, and you then need to know to use the y-intercept, and then you use the rise over the run in order to graph. So now, if it's not in slope-intercept form, that means it's in standard form. There's only two different kind of formats we're going to learn. So if it's in standard form, again, we gave you a sheet that had the steps to graphing. It was a white sheet, not a yellow sheet. I wish I had done it in yellow also. But it tells you how to graph when it's in standard form. It says all that stuff about plugging in 0 for x and then solving for y. Then plugging in 0 for y, solving for x. So you could just write in your notes, use the white sheet, and then make sure you have the white sheet. Or this is kind of a summary of how to do that as well. It says make x equal to 0, then solve for y, then make y equal to 0, and solve for x. That's a very, very brief summary. So if you don't understand that, you're going to want to use the white sheet. But if you then you don't really need the white sheet. All right, so that's how we know which way to do it. Now let's do some examples. I went over in class what the mistakes were on the exit ticket, the common mistakes. I'll kind of include some of these or some of those when I do the examples here, but I'm not going to probably go into as much depth as I went into during class. So here we go. I'll give you an equation, and then you're going to graph it. Pause the video. Try to do it on your own, then you can check your work. So let's say I gave you this. First thing you need to ask, which method do I use? Which means you need to ask, is y all by itself on one side of the equation? Well, here's the y. That separates the sides. Yes, there is only one thing on the left side of that equation, and that is y. So y is all by itself. That means I need to use slope-intercept form. Slope-intercept form, which means I can either use the yellow sheet, or if I already feel pretty confident, I just need to know that I'm going to use the y-intercept and then rise over run. So let's go ahead and graph it. Some of the common mistakes, one of the things I want you to think about. If you see a subtraction sign, a negative sign, I don't care what you want to call it, that sign is glued to whatever number follows it. So this negative sign right here is glued to that 2. Wherever that 2 goes, even if we just talk about that 2, that is a negative 2. Same way with this sign. It's in front of the 1/3. Whenever we talk about the 1/3 fraction, we're going to say negative 1/3. If we write 1/3, we're going to write negative 1/3. The sign is glued to whatever number follows it. There's too many mistakes are being made by missing that sign. So we're just going to think of them as being glued together, whatever follows it. So I'm sorry, whatever follows the sign. Or you could say the sign that's in front of a number. They are glued together. So again, these two are glued together, and these two are glued together. All right. So with that in mind, I'm going to go ahead, and I won't take off for this, but if let's say you get something wrong and you've done this part correctly, I can at least give you some partial credit. If you don't do this part and you get stuff wrong, I can't give you any partial credit. First thing we need to do is pull out the slope and the y-intercept. So the slope is the m variable. If you don't remember that, the y-intercept is the b variable. And this comes from the equation y equals mx plus b. M is the slope, b is the y-intercept. So I'm going to let you pause this and think about what it should be. You should be back now if you paused it. So two things that I need to remember. First of all, the slope is always the number in front of the x. It doesn't matter what the first number is, what the second number is. Slope is the number in front of the x. It's the number being multiplied times the x. Oh, and then I guess three things to remember. X is never part of the slope. Never. Never, never, never. It's two separate things. It's the slope times the variable x. So whatever's in front of the x, which in this case is the 1/3, but we need to remember the sign in front of the 1/3 is glued to that 1/3. So we have to write that negative sign in. So that's my slope. The y-intercept is always the number that's always by itself, not with the variable x. So there's my slope and my y-intercept. Now I can use the steps on the yellow sheet. If you don't know what the yellow sheet is, let me see if I can find it really quickly. I know it's in here somewhere. Let's see. Is this it maybe? No, that's actually the, so that's standard form, so that's slide 32, I'll remember that. Maybe it is, I had two graphs on it, where is it? I changed it around, so I'm not, oh, there it is. Yeah, I changed it around, so this won't look exactly like your sheets if you have the sheet. I changed it a little bit, but this is the one I'm talking about. See how it says steps to graphing slope-intercept form? And then it had two examples on there. I think your sheet, the examples are on the right-hand side, and one of them is above the other one. I changed it around to make it look like this. But again, the steps are the same. This section right here should be the exact same for the most part, unless you have an older sheet, and then I might have made some changes. You should have underlined this section and this section. You should have that. And then I think the rest of it should be pretty much the same. So now let's go back to our problem we're going to do. Is that it? Yeah. All right. So first step, it says put a point on, oh, it says put a point, and then it says in parentheses x and y coordinate. Something like this, x and y coordinate, something like that is in the first step. Get rid of this. Just get rid of all of that that's in parentheses. It's not helping. I really think it's hurting more people. People aren't understanding what I'm saying. I'm just telling you that all a point is it's an ordered pair. It's an x and a y, but it's confusing people. So just get rid of that so that it reads, put a point on the y-intercept. All right, well, the y-intercept we've already pulled out. It's this -2. If it is the y-intercept, it needs to go on the y-axis. This is the y-axis, the up and down. Way too many people are putting that first point on the x-axis, the left and right axis. It does not go on the left and right axis. It goes on the y-axis. It's called the y-intercept. It goes on the y-axis. So I'm going to put a point on -2. So again, that will be down here. Not here, down here, where I just put the point. Now, from that point, step 2 says if you do not have a fraction, well, I'm going to start right there because my slope is a fraction. It's a fraction right there. So I have a fraction. So next to step 2, if you want, to the left, if you have room, you may not have room, possibly, but you could write, if you already have a fraction, go to step 3. Because you only do step 2 if you don't have a fraction, which we do have a fraction. So the third step is where a lot of people are skipping and they're not writing down rise over run, and they're making mistakes. I saw tons of mistakes right here on the exit ticket. Write rise over run, and then write the fraction next to it. If you have a negative number as your slope, make the top number negative. Do not make the 1 and the 3 negative. Only one of them. And I always do the top number. So now I have everything I need. If you didn't write this down, I have it on another slide. I'm just going to write it right here. If it is a positive run, then you count right. Negative run, and you almost never have a negative run, by the way, if you do it the way I've told you to do it. So that makes it pretty easy because you know you're always going to count right. Whoop, I'm going to have to move that up a little bit. Oh, the part I'm doing right now, by the way, this is pretty much step 4 and step 5. I'll do this so if I have a positive rise, I count up, and if I have a negative rise, I count down. So 4 and 5 basically tell you all of that same exact stuff. Fix that quick so it doesn't delete. So now, that means I have a positive 3 as my run right there. So I would count, it tells me right here, positive run, count right. So 1, 2, 3. I call it hop 3 instead of count sometimes. Then it says I have a negative rise. So it says if I have a negative rise, count down. And that's where my second point goes, and that is my line. So my line should look like this. Now, a lot of people miss this on the exit ticket. There was one pretty similar to this. And they should have known immediately they missed it. So that's the answer, by the way. So you're done. That's the answer. I'm about to do some stuff that was missed on the exit ticket, mistakes, basically. They got the Y-intercept correct. And they put that in the right position on the -2. And then they graphed it, and they did count 3 to the right, but they wound up with a line that looked like this. You should know immediately that that is wrong. We did this as the very beginning of the lesson about slope and y-intercept and slope-intercept form. If I have a line that slopes up from left to right, we said if I'm on the left side of the line, and if I'm walking uphill, this is for any line on a graph. If I am walking uphill, which I would be if we always read from left to right, so I'd be walking uphill on that line, then that is a positive slope. Uphill means it's positive slope. Well, if I look at the equation, I have a negative slope right there, negative. Well, that's not right. Those are not matching up. So you should have known immediately that you had the wrong line if you graphed a line that was sloping up from left to right. Yet way more than half the people had a line that sloped up instead of down when the slope in the equation was a negative slope. So just make sure you add, actually in class I told them to add that onto the final step. Boy, I don't know if I added that on or not. I'm going to look at it real quick. The final step on that step sheet, I want you to write in, I think I did write it in there, maybe. I don't remember. On the new version, maybe not. I'm going to put it in there right now. Why is that not? Oh, it is there. I'm sorry. Oh, steps to graphing, final step. Yeah, so right here. When you are done, make sure the slant of the line matches the sign of the slope in the equation. So that's what that means, is if your line is going up from left to right, make sure the slope in your equation is a positive slope. So that's what this little thing right here means. I'm going to put a little asterisk next to that. So that's how you do. I'm not going to do another example. You have plenty of worksheets you should be able to use to practice if you want to practice. You can do these two problems right here. Actually, here, I'll just do these real quick. So practice these two. Try to do these on your own. We didn't do these in class, but for people watching, since they got more practice in class. So I'll let you think about it. Do both of these. Again, y is all by itself, so I know I'm using slope-intercept form. So I answered that question. Pause if you haven't already paused and try these. So you should be back now. First step, pull out the slope and the y-intercept. Y-intercept is not a y though, it's the variable b. All right, well the slope is -1/2. Y-intercept is 2. I'm just going to do it over here also while I'm doing this piece of the problem. Slope is 2, -5. Whatever's in front of the number sticks with the number. So that is a b, by the way, if you don't know. That's b for the y-intercept. All right, so now I start with the y-intercept. I'm going to do both of these graphs kind of at the same time. My first point goes on the y-intercept, which is +2. Over here, it's a -5. So it goes on -5. So there's my first step in both problems. I did the y-intercept. Now I need to write, I don't have a ton of room for this. Where can I do it? Shoot, I guess I'll just write it really, really small, maybe on the left side of each equation. Yeah. I'm going to switch colors. Sure, we'll do that. That'll stand out better. So I'm going to write rise over run. Next to that, I'm going to write the slope. Well, it's a negative slope, so I'm going to make the top number negative. There's my rise and my run. So if my run is +2, and again, you should have this on the other page. I don't believe I put it on this page, like which directions you go and all that stuff, but you could use step 4. So again, if the run number is negative, go left. If it's positive, go right. If the rise number is negative, go down. If it's positive, you go up. So I'm kind of using that. Well, my run number is positive. I go 2 to the right. My rise number is negative. I go down 1. And that's pretty much where my line would go. Kind of missed the points, but that's okay. So that would be the way my line would go. Over here, I'll do the same thing. I'll write rise over run up top. Now, the second step, it says to make your slope into a fraction if you don't have a fraction. And I do that by putting it over a +1, always over +1. So next to this, then I write 2 over 1. So my run is +1. So again, that means to the right 1. And it's my rise is a +2. That means up 2. And there's my second point. And there we go. So that's how you graph slope-intercept form. Let's do one with standard form. Again, this is just a repeat of everything you did in the last video, if you caught up and watched the last video. But I'll do one more. So let's down here. Let's say we have an equation like this. Oh, can't do that. Scratch that. All right, so there's an equation. X plus 2y equals -6. Y is not all by itself, so that's how I know I need to use standard form, not slope-intercept form. So I can't just, there's no slope. There is no slope, no y-intercept in this type of formula. That's only when y is all by itself. So I've got to do the whole process of plugging in 0 for x and then solving for y, and then plugging in 0 for y and solving for x. So if this is my equation, I'm going to plug in 0 for x, write the rest of the equation, nothing else changes. Now I just do the math. So that 2y equals -6, divide by 2, divide by 2. I get y equals -3. Now, a lot of people, for some reason, are trying to say that that's actually x equals -3. Well, no, it's not. X is 0. You just plugged in 0 for x right there. X is 0. So my coordinate would be 0, comma, -3. Because I plugged in 0 for x. So x is 0. So y is -3. Well, I just need to go to where y is -3 on the y-axis. Or you can think of it as plotting the point 0, comma, -3, because that's what that point is, really. So there's my first point. For my second point, I'm going to do it in red. Now, again, I write the original equation, starting all over again. Now, though, I'm going to plug in 0 for y. Well, 2 times 0 just goes to 0, so I don't really need that anymore. I guess I'll write it out. So that means x equals -6. If you want to think of that as 1x, you can. Divide by 1, divide by 1. You really didn't need to. And you get x equals -6. -6 divided by 1 is -6. So now I go to, and again, the point, the coordinate, the ordered pair would be -6, comma 0 if you wanted to write it out. But basically, I just go to the x-axis and I find -6 and I put a point on -6. So that's where it goes, right there. And then that would be my line right there. So that's how you graph. And there's a white sheet that I gave out. You may not all have that if you missed a lot of class, because we only did it one day in class. I can give it to you when you come in if you didn't get it. But it's a white sheet, and the title of the white sheet says Steps to Graphing a Linear Equation in Standard Form. And that's what we just did. We plugged in 0 for x, solve for y, plugged in 0 for y, solve for x. That was a summary of October 25th.